In my previous video, I talked about how to implement WakeOnLan from scratch by creating a magic package using Python and Go. Then I made a web interface for WakeOnLan, which you can use to wake up your computers remotely with just one click on your phone. Installing this web app is very easy. First of all, we need to clone the GitHub repo. And all the deployment instruction can be found here in deploy.markdown. And the simplest method to deploy is make deploy. We're using makefile here. So now it should be deployed. The default port I'm using is 1990, so localhost 1990. The website is running now. Let me briefly explain the makefile. What I ran was deploy, and it ran download frontend first, which is here. It will go to GitHub repo, find the latest release, and download the compiled frontend from the latest release. This is because compiling the frontend takes quite some time, so I decided to just download the latest release. But if you want to build the latest frontend, you can also run make build frontend. After downloading the frontend, it will run Docker Compose up with detach. So if you're running for the first time, or if it doesn't deploy for you, you can try to run deploy test. It will download the frontend first, then run Docker Compose up without detach so that you can see the error messages. So I'm gonna do this, Docker Compose down, to shut down my previous containers. Then I'm gonna run make deploy test. Remember that it's the same as Docker Compose up. So when you see database system is ready to accept connections, that means the database service is running properly. And when you see this, that means the server is also working properly. And this page can be loaded. Next, let's talk about the Docker Compose file. There are basically two services in this Docker Compose. A database service, which is using PostgreSQL as a database to store all the user information and computer information, like MAC address. The second service is called backend. It's a Golang server hosting the front end and also serving some APIs. The front-end code downloaded from GitHub will be stored in this location and will be served with the server. Both of the two services depends on this .env file, which contains all the environment variables for the two services. So let's have a look at it. Port is the port the server will be running on, and JWT is for JSON Web Token. The Postgres environment variables are for the database, and we will be talking about this in a minute. Make sure to keep this file private. If you need to change the port, you can simply edit this environment variable. So let's say 1991. And let's restart the server. So this time it's running on port 1991. So let's change the port. Great, it's working. There are many other options to deploy, and I want to talk about this Docker image option. I host this website on my Raspberry Pi, which has a different CPU architecture. It's using an ARM CPU, and deploying this website using the previous method with Docker Compose sometimes doesn't work on it. I'm not sure why that happens, but Docker image is another solution. I'm going to demonstrate how I deploy this app on my Raspberry Pi. First of all, I need to SSH into my Raspberry Pi. and go to the directory where I cloned this repo, and then I'm gonna just run this command. I will need to add the following into the image name: arms32v7. This is because I'm running this app on a Raspberry Pi, which has the ARM CPU. And if you're not sure about the image name, you can go to Docker Hub Postgres and find out the supported architectures. I'm using this one, and there are some other options you can use. If you're using a 64-bit Raspberry Pi, you may want to use this one. So, and we can verify that the database is running on Portainer. The Portainer container is running on my Raspberry Pi. And if we look at the log, it's ready for connections. And next, we need to start the server. And remember that you need to run these commands within the WOL directory, because it relies on the pwd. It relies on this to find the .env file. And also, it's also saving the database to a directory. It's binding this directory as a volume. So let's start the server. So for the tag name, instead of latest, I'm going to use Pi4. I made this image, and you can find out more information here on Docker Hub. Here are all the tags supported. This tag is called Pi4 because it's only tested on Raspberry Pi 4, but it should work on other Raspberry Pis. Okay, so the server is started, and let's verify. Yep, it's running. After talking about deployment, I want to talk about how to use it. So for now, we only know that the website is hosted, but we don't know if the functionality is working. I changed the port back to 1990 and restarted the server. So now it's running on 1990. And let's go to sign up, since we don't have a user yet. You can see there's a user quota here, 0 out of 1. And this corresponds to this environment variable, num-user allowed. Default is 1, which means there's maximum 1 user allowed to sign up on this website. This is to prevent many people from signing up and waking your computers up. So I'm gonna use user password. Make sure you use a better password. I'm just using password here. And then the computer list is empty, so we need to find a MAC address and give it a name. I will call it Ubuntu. And yeah, a computer is added. You can also configure other parameters, but by default, this should be the parameters. When I click this button, a magic packet will be sent. In order to make sure that it's working, we need to use Wireshark. So sudo Wireshark. I talked about more details about magic packets and WakeOnLan in my previous video. Now, if I send the magic packet, it should show up here. Yep, it's captured. And I'm now sending a magic packet to myself, but if you're sending a magic packet to other machines, it should work too, because it's broadcasting, so everyone should receive it on the network. Now I'm gonna start another computer. Let me get the MAC address of this computer. And I will add it here. Okay. Let's send another packet. So this time let's wake Kali. Notice that the magic packet appears on both computers. And if we send the packet to Ubuntu, the magic packet should also appear on both computers because it's broadcasting. But only the computer with the MAC address will be wakened. Next, I'm going to show you how I use WakeOnLan remotely. So first of all, you need to connect to your home VPN. It shows that I'm connected to Wi-Fi, but actually I'm not, because I'm connecting to my laptop and it's displaying Wi-Fi somehow, but I'm not connected to Wi-Fi. So I'm going to connect back to my home. When it's connected, I can go to my browser. Since I'm not using Wi-Fi, the local DNS no longer works. So I have to enter the IP address of my Raspberry Pi manually. Then send a packet. 3, 2, 1, send. This project is written in Vue.js and GoLang. It's my first Vue and Go project. I made this to practice my skill in Vue and Go. So if you're a Vue or GoLang developer, feel free to point out any place I'm not doing correctly or send a pull request. I will include the GitHub URL in the description.